there, everyone. We're going to go ahead and open the Zoom room early just to let folks start to come in. You may see a QR code on the screen in front of you. If you scan the QR code with your phone or a device near you, you will be able to access a free trial of Vernier Video Analysis. I believe the free trial will last 60 days, so you can follow along today and then maybe test it out yourself. Am I missing any details, Fran?
That's correct. And this 60-day license does allow you to use it with your students.
Very cool.
Obviously, we are trying to get you hooked on using it so that you will then purchase the full license later.
And if you have any questions, feel free to pop them in the chat. You'll be able to access the chat window just at the bottom of your Zoom screen there. If you click the chat button, it'll pop up, and just make sure that you're sending that question to everyone so everyone can see what you are asking. Otherwise, it starts to look like we're having a one-sided conversation. So we'll share the wealth, share the information.
Yeah, and as Fran mentioned there, the that 60-day trial version thing is one that we've done at the NSTA and the other, a lot of other workshops. We've all had the experience of trying something out on your own, but then that's not the same as turning it loose on a group of 16-year-olds. So that's why we do the trial we do, so you can really try it out. And that's honestly, this is one of my favorite tools in the Vernier arsenal, because I've been doing digital video since 1992 that involve laser discs. Dylan probably doesn't even know what that is. Most people didn't. It was pretty obscure, but now like the cameras are just amazing, and students really can do some fun creative things with it. So anyway, this is one of my favorite topics.
Yes, so let's get started. I'm going to go ahead and move us along in the slides so that you can see the title. You are here for Exploring Projectile Motion, Circular Motion, and Conservation of Momentum with Vernier Video Analysis. And you are with myself, Fran Poodry, and Jake Hopkins. I, Fran, am the director of physics here at Vernier. I taught high school physics and other levels of physics for just over 20 years before coming to work here at Vernier, and done a lot of video analysis. Jake, you want to say a couple words about yourself?
Well, my first video analysis use was in the workshop physics program at Dickinson College, and back in the day, it was a lot. It was a little clunkier, shall we say, than it is today. But I am one of the physics folks here. I'm also one of the partners in the company, and sometimes informally referred to as the Alpha Geek. But today, I'm just the chat geek. So I'll answer any of the questions by chat, and then serve them up to Fran, who's the subject matter expert.
All right, and then Dylan is here with some housekeeping items.
Awesome. Thank you so much. Before we get too far into the webinar, I wanted to let everyone know of a few behind the scenes things that you may be looking forward to. First and foremost, you will have access to a recording of this webinar. It will be posted both on our website and our YouTube channel as soon as it's ready to go. That typically takes about 3 to 5 business days, but once it is edited and beautiful, it'll be up and you can watch it and share it and use it however you wish. We will send you an email with a link to this video as well, so you don't have to be checking the website every day. We'll make sure you get it, and we would love to answer your questions during today's webinar, so please use that chat box, send us all of your questions, and if we don't happen to get to you, feel free to reach out to us, or we'll follow up with you via email. So
all right, and then Dylan, did you have a poll?
I sure did. Yeah, let me go ahead and launch that.
All right, do I need to stop sharing for that?
No, that should be able to go while we're sharing. So everyone should see that.
I see it too. Okay, so this poll will help us understand who you are and kind of what level you're at. Have you done this before? I know some of you answered the question in the registration. If you have any questions, some of you have been using Logger Pro, some of you have been using video physics. No one mentioned using Tracker, but I know a number of people use Tracker. And then, of course, if you already have experience with Vernier Video Analysis, hopefully you'll learn a few new tricks and techniques with today's webinar.
But Dylan, it says that hosts and panelists can't vote, so I can't give my answers. I just need to see everyone else's. That's okay.
Oh, I'm actually, there's a whole bunch of people who haven't used video analysis. So I hope this is a good introduction, and I hope that you get inspired to do some work with it with your students. I think students do really enjoy using it. All right, let's see. So what is Vernier Video Analysis? Actually, before I move on with this, real quick here, just so you know, we're also going to give you a link to a Google Drive file, and in the Google Drive file, you will get all of these slides. You will also get this thing, which is my outline in text form for this webinar, so that you can see all the things that we talked about. That might help you if you need to scan through and scrub through the webinar recording to find what you're looking for. That outline might help you. You're going to be getting 3 sets of instructions for doing these video analysis experiments, and you will receive the videos that are in that folder that you can use for those experiments. So you'll get that link. Dylan just put it in the chat, but we'll try to also remember to put it in at the end so that you can get all that information. So let me go back to sharing my lovely slide presentation. What is Vernier Video Analysis? So Vernier Video Analysis is a progressive web app. What does that mean? It runs in a browser on any platform. We do recommend using Chrome or Safari. So you can use Chrome on any platform. You've got it on your Chromebooks, obviously. You can have it on your Windows or your Mac or your iPad or your Android tablet or your phone, whatever your phone is. And then if you're using Safari, that works as well. If you're using Safari on something like an iPad, Chrome on the iPad is actually like a Chrome skin on Safari. So you're using Safari either way, but it works on those. We don't recommend Firefox. Our apologies for that. Unfortunately, Firefox has its video capabilities are just not that great. It's missing some codecs. It doesn't have good support for finding individual video frames. So it mostly works there, but there are some issues. So we don't really recommend that. You would use this because it allows analysis of motion that cannot be captured easily by sensors. So specifically 2-dimensional motions. It's very easy to use a motion detector to get 1-dimensional motion, something speeding up, something slowing down. But as soon as something goes into circular motion or as a projectile, then your motion detector isn't so great. And if you're trying to track 2 objects, such as in a collision for conservation of momentum, then you need 2 motion detectors. Or 1 video. And there are some other experiments in our books that, which I'll get to in a moment, that also it would be difficult to analyze the motion any other way. And so Vernier Video Analysis includes some great features. It includes auto tracking. Auto tracking was available on our iOS app, Video Physics, but was not available in Video Analysis on Logger Pro. However, in the Video Physics app on iOS, you were not able to actually do the analysis, do any calculated columns, actually get the equation. You'd have to export the data to something else in order to do that. In Logger Pro, you could do that analysis, but in Vernier Video Analysis, you can do both Cartesian and polar coordinates, which I will be showing you today. And that was not, the polar coordinates are not a feature in Logger Pro. So we're getting, you're getting more stuff, more features, more abilities with Vernier Video Analysis than with other options. And then you also have with this custom curve fits and custom calculated columns. So lots of stuff. I know some people have been interested in what our pricing is. So your better deals are always going to be if you buy multiple years at once. Only the 1 year and 3 years are like available directly on our website. But if you want the 5 year, you just call us or email us or use the chat on our website. You can get special distance price, district license pricing. So if you're the supervisor in charge of science for your district and you have, 4 or 5 high schools, or a smaller district, you might have 2 high schools, but you still it's worth their time to call us up, email us, and get your pricing for your district. And I know that some of you are at very small schools where you might have only like 5 kids in your physics class. And in that case, it's more economical for you to just get the individual licenses. You would need 1 for each student and 1 for the instructor. And those would be $15 each. Again, not available through our website. You do have to call us or email us, but that is available for you.
So lots of options, but the most popular by far is to do the 3-year kind of regular size school license, and that ends up being $150 a year. There was a question in the chat there that is a school-wide site license, no limit to the number of students, and then you only have to talk to the billing people every 3 years.
Thank you for keeping track of the chat, Jake, because I am not paying any attention to it. And again, Jake will also, please feel free to interrupt me if there's a relevant question that comes up in the chat, and because I'm not going to see it.
What if it's an irrelevant question?
Don't ask it.
Okay.
Thank you. All right. So where can I find the instructions for analyzing videos if I'm going to use this great app? So number one, there's actually a user manual that you can access from within the app that just gives you straight up instructions. It's kind of long. So you might also look for these 2 ebooks that we offer, Vernier Video Analysis, Motion and Sports. That's the one where the 3 experiments I'm showing you today are coming from. And then Vernier Video Analysis, Conservation Laws and Forces, which is it's the slightly more complex one, the 2D collisions. We've got a pendulum that swings down and turns into a projectile. We've got some energy analyses and things that are more than just your basic motion. All of the experiments are included, have 2 versions. There's a guided version, which has complete instructions for collecting all of the data as well as the analysis. And then there's also an abridged version. So if you are doing all of the experiments, by the time the students are doing the 4th one, they're gonna be like, all right, I know all this. Where? So in the abridged ones, the instructions are things like mark enough points to be able to understand what the motion is. It's not, it's not saying, okay, first click here, then click here, then click here. So it's the abridged version. And so consider using those with the students who've done this before. Each book also has very helpful appendices on how to capture videos with lots of tips for getting good ones, preparing the videos for analysis, doing the analysis, and there's actually ways to get better values for velocities than just using the straight up velocity column sometimes. And so there's an appendix on that as well. The instructions that you get in the ebook can be delivered to students as is, or you can modify them however you like. So you do get editable files as well as a PDF. Let's see. Oops.
So
example.
Fran,
yes.
A question about how the 2 new ebooks compare to the older Physics with Video Analysis book.
Oh, that's a great question. So the Physics with Video Analysis book was specifically written for use with Logger Pro. So all those instructions are like, go to this menu in Logger Pro and choose this thing and use this icon on the Logger Pro Video Analysis to click on it, and then you're able to do this. And all of those things are pretty different in Vernier Video Analysis. So these books, these ebooks, they've got Vernier Video Analysis in the title because they're specifically geared towards this piece of software. The books do include the videos, by the way. So you could use the videos with Logger Pro. You would have to rejigger the instructions. All right, so getting on to the actual examples, we're going to start with projectiles. Projectiles are the classic that you would do with students, physics students, whether it's in conceptual physics, we still did projectiles all the way up to AP physics. You're going to do projectiles. If you're doing introductory physics in college, you're still doing projectiles. So it's the classic. And the things that I am going to show off for this are adding vectors to the points and creating custom calculated columns, because we're going to do some energy stuff with that. So let me pull up that, let's see, screen sharing, new share, and let's do the video analysis. All right, so you should be seeing my screen. I prepared this already by already collecting some data on this basketball toss video, very classic. And I'm not going to run through how do you do each one, because that's going to take us way longer than the time we have. So I'm really just highlighting specific features and showing you how to use those specific features. There are, I'll show you towards the end, more resources for how you do them elsewhere. So anyway, so I want to show adding vectors. It is under the add, if you click on these, you get different things, but under add, this is where you get vectors. And the vectors let you add vectors for position or velocity or acceleration. And they let you do scale factors for velocity acceleration. And they let you show how many, basically how dense you want your vectors to be. You could put them on every point, or you could put them on every third point, or every apparently 14th point. So I just want to show you position. So this little eyeball with a slash through it means we're not showing it, and now we can show it. Whoa, look at all those vectors. So obviously the position vector is measuring from some origin. I think I might want to move that origin. So I'm just going to click through these until I get rid of them for a second. I'm going to go to system and I'm going to put my origin. Let's see, go back. Yeah, so it's kind of lined up with where the basketball starts and where ground level is. And then I'm going to real quick add the scale so that we know what we're working with here. All right, now back to vectors. And if I show the position vectors, let's give you a little play. Whoa, there we go. So right now I'm showing all the vectors. I'm showing the position vector for every single point, and I'm also showing the components of those vectors. So this little icon here says, all right, this is the resultant vector, and this is the component vectors. You can also show just the total vector, the magnitude vector. You can show just these position vectors. Let me actually toggle these off for a second and see. Yeah, they're all pointing from the center point from the origin. So not that helpful. Velocity, however, these are the vectors that we normally use, right? So these vectors, again, you're going to see the components, and you can see that the component for the horizontal component of velocity looks pretty consistent. and the vertical velocity does not. You can even see up at the top where it switches from going positive to going negative. And this is where we might want to change how often we display these vectors so they're easier to see. So that's where the vector frequency display comes in. I can change this so I'm just showing the resultant vector. What is the actual direction of the velocity of this basketball, or just the components? And here it is very clear. Some of these vectors go off the screen. That's not a surprise. You can change the scale so more of them go off the screen, or you can change the scale so none of them go off the screen. You kind of have to choose what's going to be best for your particular display. Are there any questions about the vectors? Not hearing anything from Jake. All right. I'm going to go ahead and get rid of the velocity vectors and put in the acceleration vectors. But before I do, I want you to think, what direction or directions do you think the acceleration vectors will be in? You don't have to answer in the chat if you don't want to, but think to yourself, which directions are going to be? There's Jake getting out his vector fingers. All right, ready? Interesting. All right, I'm going to go to just these vectors. Were you right? I'm going to scale these down a little bit. Notice that if you got the question right, you'd be thinking, oh, they should all go straight down because we're combining constant horizontal motion with an accelerated vertical motion where the acceleration is in the downward direction because we're on planet Earth, and we know that the gravitational field strength is giving us that acceleration of negative 9.8 meters per second squared. So we don't get exactly right because I'm not perfect at putting my little dots on things. So yes, John McLean has a great answer there because the velocities were calculated from the positions, which had slight errors. Could be a pixel off, sorry, yeah. But that's gonna happen with your students. And that's also one of the things that's great about this because you're working with something that's real. It is a video, but it's a video of a real thing. It's not a simulation. It's not a theory. Oh, and yes, John Durkett is pointing out that there's a very large upward acceleration when the ball bounces. So yes, lots of fruit for discussion here. So this is great for working with students. The next thing I want to talk about with this is creating some custom calculated columns. So in order to do that, I'm going to go and show not just the video, but the graph and the data table. In fact, I'm going to get rid of the video, so we're just looking at the graph and the data table. So in my data set, I've got all of my times, I've got my horizontal positions, I've got my vertical positions, I've got my horizontal velocities, I've got my vertical velocities. What if I wanted to explore the energy in this? Well, it's easy to explore kinetic energy, potential energy. Potential energy, gravitational potential energy, is based on the vertical position. So if I just look at vertical position, this should be essentially what the gravitational potential energy graph looks like as well. And I can put a calculated column in by clicking on those three dots and adding a calculated column. I'm going to say potential energy, I'm going to say joules, and I'm going to insert an expression, and this is where you can do a custom expression. So there's all of these things, but I want to put, let's see, my expression is going to be the mass of the object times the acceleration of gravity times the vertical position from 0. So I'm going to put in a custom expression for that, and I'm going to type in, all right, the mass. I'm just going to ballpark this. I don't actually know what the mass is, but I'm going to call it, 400 grams. So 0.4 kilograms times 9.8 times, and then I want the vertical position, which is Y. And as soon as I type a letter, I get my column options, and I'm going to choose the Y column. It automatically puts that in. Oh, I see.
You are looking at the chat,
I
Fran.
am looking at the chat.
Apparently, the regulation mass for a sports ball is 625 grams.
Thank you, Joseph Vanderway. I appreciate it. And then I'm going to apply this. This gives me a new column for potential energy. And because I just did this calculated column, it actually changed it. So now I'm looking at the potential energy. And if I used both the potential energy and the vertical position, you can see that they do, I'm going to change the color of that. They do actually follow the same up and downness of it, but the potential energy is appropriately scaled larger. If I wanted to do kinetic energy, I need to know what the magnitude of the velocity is, and I can do that with another calculated column. I'd have to use the magnitude of the velocity using the x velocity and y velocity. So I'm going to add a calculated column for total velocity in meters per second. And for this, I'm just going to use the nice resultant calculation here. So the square root of x squared plus y squared. I do have to tell it I want to do this with x velocity and y velocity. But once I do that, then I will have a total v, and then I can do another calculated column for kinetic energy. I'm running short of time, so I'm not going to do that, but you can see that we've got great features in here. I'm going to move on to, let's see, I want to do circular motion next.
Too late.
What?
There was one about, can you predict the further movement of the ball after the video ends?
Oh, sure. You can do that by, let's see, if we wanted to look at the X and Y again, I would do that with a, looking at an extrapolation of the data, which I can do by applying a curve fit to that bit. I want a linear curve fit. I'm going to apply that. And then I'm going to extend this. So I'm going to edit the graph option. So instead of going to 1.8 seconds of time, I'm going to go to, I don't know, 5 seconds of time. And now I can, oops, disappeared. Curve fit, linear, apply. Wrong part. I was not prepared for this question. All right, so now I've got my linear fit on here, and if I want to know what's going to be out here, I'm going to have to turn on interpolate. And now if I move to some other point on here, then I can show what the horizontal position would be. For the vertical position, I'd have to use a quadratic to do that one. But yes, you can predict what it would be in the future. And I see someone's coming up with a question that I'm going to get to in a future example here. So let me move on. Moving on to circular motion, I'm going to cover 2 things in circular motion, and that's using auto tracking and applying polar coordinates. Neither one of which can be done in Logger Pro, but you can do auto tracking in the Video Physics iOS app. All right, so I am going to auto track this because I happen to know that this movie has a lot of frames. And so I'm going to focus in on that red dot, and then I'm going to start auto tracking. Oops, lost it. This is going to happen sometimes. I'm going to try maybe making this slightly bigger. Right, auto tracking.
So this comes in really handy if you have a video with lots and lots of frames, which modern cameras can do a lot better than the old Laserdisc data had. So you could get lots and lots of data points in a pretty short amount of time. And this just kind of automates some of the tedium. But I like to not show this to people right away, because like understanding the idea that you're really just taking whatever happens in this video and overlaying it with a coordinate plane, where is the thing in relation to the rest of the coordinates, that's the gist of this data. But in this case, doing it circular takes it into a whole nother realm, which is fun.
Yeah, I mean, we've already gotten to over 100 dots, and your students will not enjoy making all the dots. I know this because I have had them do this one by hand, and I had them do it in Logger Pro more than 10 years ago when I did this with my AP physics class, and yeah, they did not enjoy it. So the auto tracking is fantastic. I'm going to go ahead and stop it there. And very nicely have our data. You can see very nice sinusoidal curves there. It's a godsend. This also works really well if you're doing something like with a really slow acceleration and you've got a lot of data points. So like a lot of the data points are really close together at the beginning, and it's really annoying to try to move your mouse or your trackpad finger just that tiny bit amount. So this is very useful. So auto tracking is great, but I also wanted to show polar coordinates, which is something that Logger Pro did not have. So in order to do that, I'm gonna have to go over to the system. I already put in the scale here, and I did put in the origin to be the center of the motion. When I clicked on origin, that's when I got my options for Cartesian and polar coordinates. So I'm gonna go ahead and choose polar coordinates. So when it does that, it does two things, and I'm going to get rid of the video so I can show you these a little bit better. So on the data set, it adds in a column for radius, a column for angle, a column for radial velocity, and a column for angular velocity. The default graph is always showing positions. It's showing X, Y, and it's also showing R. It does not remove the X and Y information. But of course, you can change what you're showing. Honestly, I don't think X is very interesting or Y is very interesting here. Ooh, look at R. This is when you're zoomed into all of the data. I'm going to even get rid of R, and I am going to go to theta, the angle. So what is going on here? Think about it a moment. So why did we get 3 segments of this graph? So if you've thought about it a moment, the reason we get those 3 segments for this graph, yes, thank you to Ray, 2 pi is a circle. And at the beginning of the video, it was actually not at 0 angle. It was at a little bit more than 0 angle. And then the rotation was clockwise, which is the negative direction in terms of rotational motion. So it got to 0, and then it went up to 2 pi and kept going all the way around the circle. So it got to 0 again and went back up to 2 pi and kept going all the way down back again. So there we go. You can, sorry about that. I had to I went because I got a phone call. It showed up on my computer screen. I had to say no. All right, so you can go back to the video. This is really cool. And go back to this, and you can actually change the angle here a little bit. And when you change the angle, it's actually going to take a moment and it's going to recompute everything. So now our data begin at the 2 pi, and then you don't get that little bit at the beginning. And that's another really cool thing you can do. It is possible to get it back straight. I don't think I did, but anyway, cool options with using circular motion. And then the last thing I've got is one more example with momentum, the conservation momentum. I saw a question that was about this earlier. So with this, we've got a few of these videos from live photophysics, which are ancient in the world of technology and video cameras and resolution in video cameras, but they are fantastic videos, so we're keeping them. So I'm gonna quick get some points for these, and I can get these quickly because it's 10 frames per second, and honestly, these are really quick. So I'm just gonna quick get these points. I'm not being super careful here to just mark each point for this little cart. And now it's staying in the same place. So I'm going to keep going with all of these. And then now I'm going to go back to the beginning. I'm going to choose to add a new object. And so when I add a new object, I get object 2. I'm going to change the color of it because those colors are pretty similar. So I'm going to make this more of a pink. So there's my second object, and I'm going to start tracking that one. And this one stays still at the beginning, so I'm going to keep it standing still. Oh, there it goes. I think I missed one. I'm going to have to go back and fix that. But anyway, here's my other object. So yes, you can track more than one object. I'm going to go, let's say, I'm going to go turn off trails. I'm going to go, why is it not wanting me to go back? All right, here we go. I'm going to go back, go back. Ah, yeah, that's the one I got in the wrong place. I'm going to edit, and I'm going to move that one to the right place. Ta-da. And then I'm going to go back to looking at these, and I'm going to show the trails again so you can see all of them and play to the end. And so here you can see that these stay totally at the correct vertical position, so I don't need to care about that, but I can care about the horizontal position, and you can see that one of my carts, my second cart, X2, is staying in one position and then it starts to move. My first cart was moving and then staying in one position, and I had previously set my systems that the origin is in the middle where they collide. So now here's the fun bit, the other fun bit. I'm going to show center of mass, but before I do that, I'm going to go back to the beginning of this and say, all right, both carts were 524 grams. I can give them names such as left cart and mass 524. This doesn't have to be grams. You can make it kilograms or pounds. It happens to be grams. Boy, is that not how you spell cart. Sorry. And then I'm going to do the same thing with object 2. That's going to be right cart, and it's also going to be 524 grams. And now I am going to show the center of mass. And that shows the center of mass on the graph with the X position for the center of mass and the Y position for the center of mass. Once again, I'm going to get rid of the Y position because it's useless here. And then I'm gonna go ahead and play this video forward. Oops, let's go and get off this and back onto add. And you can see there's these little plus marks, and those little plus marks are the center of mass locations. I'm actually going to go back and play that again so you can see the center of mass locations. If you did this with a different situation where one of those carts was more massive than the other, then that would show up accordingly because of entering the masses in those details. So great stuff. I'm going to go back to my presentation now because I got some more stuff to talk to you about.
Yeah, the center of mass ones are super fun because that's one of those, it's just like in a very visual tool like this, you can show something like center of mass moving in a straight line, but that's not obvious. But once you see it constructed like that, it just kind of all comes together and kids go, oh, but wait, would it still be linear if I don't know, let's try. And it's fun to just try it in lots of different ways.
Exactly. So now I'm going to run through some information about collecting good videos and then some other tricks for videos and analysis. And I'm going to give you some resources so you can look more of this stuff up yourself. So first, for tips, there's Appendix A in each lab manual. There's one of our tech information library, TIL, that's what that stands for, articles specifically on how to get good videos. And there's another webinar that I did previously with my colleague Tom, where we also go over a lot of tips with actual showing you how those tips work. Those links are also in this in the text version of this presentation and the outline that is in that Google folder that you received the link for earlier, and which maybe we can get the link to show up in the chat again. The keys are reduce blur, get accurate measurements, and get the motion you're looking for. To reduce the blur, get that camera as still as possible. Tripod is best. If you have to just like tape it to a box, that works too. You want as much light as possible. Do it outside if you can. If you can't go outside, you can like have your old overhead projector and use that light. Increase the shutter speed. You know, that's something that you can do that with specialized camera apps on your phone. You want for accurate measurements, you want the scale object the same distance from the camera as the motion. You want the camera aimed perpendicular to the motion, and if possible, use zoom or a telephoto and record from a distance. Those will flatten the frame. There's a great demonstration in that previous video, that previous webinar, of how the size of the meter stick changes according to how close it is to the camera. And then get the motion you're looking for. So if you need to mark the center of mass, so on. So which camera? Any camera. We recommend using a dedicated camera app because you can control the frame rate, the exposure, and the zoom. A couple are here. And dealing with motion blur, sometimes you can't get a video without motion blur. Just have the students be consistent with where they mark, whether it's the leading edge, the trailing edge, the center, whatever it is, as long as they're consistent, those dots are going to be the correct time apart. And if you have them take slow-mo video, yes, you're going to need to adjust the video a little bit, possibly. You want to make the time marks import correctly into video analysis. There's this great article on that. Oops, did not mean to go there yet. Oops. There we are. That link is also in the outline. And here's a big one. iPhones. Change the camera settings to most compatible. Very important. We've got time for maybe one question, maybe two questions. We got any, Jake?
Question about how do I get this on my students' devices? So I'm not sure if you said that earlier, Fran, but the idea of the license is that it's not just your school computers, like these 10 devices. The idea is that you can get it to all of your students on their personal phones that the school has no ownership of. There's no privacy tracking, cookie craziness, selling of personally identifiable info. All that stuff is totally anonymous.
Yeah, so
in the app,
basically, you open the app, and let me go quick back to the app so I can show you this. Going back to Vernier Video Analysis. Up here in the right-hand corner, there's these 3 dots. It's called Other Options. You're going to go here to Distribute App. You're going to click on that, and you're going to get a link. This one's incomplete, so you can't see the link, and copy this one. You can click Copy Link, and you can give that to your students on your Moodle page, on your Google Classroom page. Yeah, so yes, as Jake put in the chat, email, LMS, whatever.
Yeah, the only thing we ask is you don't just paste that app on a public web page where anybody on the internet can get to it, because the idea with that very generous license is that it just makes it easy for you, the teacher, to give it to all of your students, not to everyone who is on the internet.
Am I sharing the right place? Now I am, sorry. All right. Yeah, is it still, I can't tell.
So there was another question, Fran, about hints for auto tracking. So you want to take that one?
Tips for auto tracking? Sure. So for auto tracking, it works best if it's a high contrast color to its background. So if you have white on black, great. Red on black, great. Gray on pale green, terrible. So you want contrast, and you want small. It's got to be something that always stays in the frame. Those are the main tips there. All right. Anything else? Other questions?
Not seeing other questions, and we are a little bit over time.
All right.
But we are always available.
Yes. So don't forget to go to the Google folder to access the resources for the webinar. Thank you for joining us. You can send us additional questions. So let me go back to the iPhones thing. I saw a quick question there. In settings, you might have to search for camera in order to find it, but then this is iPhones. I don't know about Android, but settings, camera, formats, most compatible. Anyway, thank you all for coming. I really appreciate you all. I hope that you learned something, and please use the resources that we're giving you, and please contact us if you have any additional questions.
Bye, everyone.
Thank you all for coming.